All right, so 3.5 that we're looking at is the exponential and logarithmic models. Same stuff we've been doing with the plugging in the calculator, but I'm going to visit some of the solving problems that with, now I've lost my train of thought, with the compound interest problems. And then we're also going to talk about half-life, which some of y'all have seen in some of your classes already, science classes and whatnot. But again, just as a revisit as well. So this is 3.5. They like to use this formula instead of the PERT formula. It means the same thing. A sub 0 is still your initial amount. E is still the number E. Whoops. Getting ahead of myself there. E is still a number, E. K is still your rate, and T is still your time, okay? Or time, if I can write. Okay, so nothing has changed except they use different variables for some reason. I don't know why, but they do, okay? Same as the PERT formula. We've already talked about our exponential growth and decay models. We've already talked about our common logarithms and our natural logarithms. Okay, so we can ask some of these questions. We're looking at if something is compounded continuously. We want to see how long it takes for them to double their money. So they're telling us that Shelby has $20,000, okay? And if we want to double that, we want $40,000. Okay, our rate is 10.5, so 10.5, if I move the decimal place twice over, I get 0.105. And we want to know how long that takes to get to double our money, okay? So just like all the solving problems we've been doing before, we're going to get rid of 20,000 first. So if you notice, every single one of these problems, the first step we do is to get rid of the principal. And if it's looking at for doubling our money, I'm always going to end up with 2 on that left side. So if they give you an example where they don't tell you the initial amount, but they tell you they triple their money or double their money or anything like that, then double their money, they put a 2 over there, triple, of course, 3. And then when we do half-life, it's just 1/2. Okay, so then I can go around the world. I have the natural log of base E of 2 equals 0.105t. If you want to, you can flip-flop this so it looks more like we've been doing our problems if you wanted to go around the world. Okay, and then all I have to do is divide by 0.105. And I get my estimated time it takes for Shelby to double her money. Yes, it changed to his. I used to do all of these in kids' names in the class, and then I forgot sometimes to change pronouns. All right, so it takes about 6.6 years, depending on if they want you to round up, you would say 7 years. Or you could, if they don't have a preference, then I won't be picky about that as well. Okay. So the good news with Part B, it just says how much money is she going to have in 10 years. So this one I don't have to solve as much for. I'm just going to plug it into the formula. Same rate, except now I have the time. So now it just becomes, can I plug it in the calculator correctly? Which I almost didn't. And I have about 57,153.02. Okay, so if it takes about 7 years for me to make $40,000. If I got anything less than 40,000 after 10 years, then I know I plugged something in incorrectly. So kind of just double check that. So those are the problems, pretty straightforward. They don't give you an initial amount, but they say it takes it to double. You can jump right over here to this. Whoops. I was trying to highlight. Right over to this step here where it says just set it equal to 2. All right, so let's look at a half-life problem so y'all can see what that looks like. Okay. So with these examples, you have to do the formula twice. They're giving you information about the half-life, and then from there, you can use that information to actually solve what they want you to solve for, okay? So for example, the half-life. I'm going to look at this information right here, okay? I don't know the initial amount. Notice how the next part of the question says find the initial amount. So if I don't know the initial amount, I'm going to look at this half-life first. So if it takes 1,600 years to have half of the material left, that's why it's 1/2 off to the side, then I need to figure out what my rate is. And all of these half-life problems are going to be solved the same way. Again, like I said, if you feel more comfortable leaving that 1/2 on the other side because it helps you with the around the world, go for it. Okay? So it takes 1,600 years to have half of the material left. So I need to figure out what the rate is. Okay, so I'm going to go around the world. So natural log of 1/2. And divide by 1,600. Okay. So from there, natural log of 1/2 divided by 1,600 is going to be a big decimal. Okay. Leave this in your calculator. Because you're going to use that information, and it's better if you keep it as pure as possible. So if you notice there's an E and a -4 off to the right-hand side, that means we move our decimal 4 places to the left. That's why I have those extra zeros up there. Okay. All right. So then from there, now that I have that information, I can solve for the rest. Okay. So if the amount after 1,000 years is 1.5, I need to find the initial amount. Well, we have our rate and we have our time now. So we've got 1,000 and we've got our rate. So that's why I was saying keep it in your calculator so that way you can keep this as pure as possible. So E raised to the 1,000 times my rate is all a number, okay? So I'm going to divide by that E raised to the 1,000 and my rate as well. So 1.5 divided by E raised to 1,000 times my answer, because it's still in my calculator. My initial amount was 2.31, okay? So you're going to use the information they give you for a half-life to find your rate, and then after that, you can use the rest of the information to find out what the initial amount is. And you're going to solve all of these the same way, okay? Try this one on your own. Again, I'm going to keep going, and then you can unpause it. Whoops. So the good news about this one is that I just want to find the amount after 1,000 years. So I can do 12 and then e raised to the 1,000 times my answer. So I will have about $10.63, not $10, listen at me, 10.63 or whatever at the material. Again, it depends on how many decimals that they're asking for. If they want you to round, you round, and so on. Okay. So half-life, like I said, they're solved the exact same way. Just get some practice in with those. Okay. In regards to everything else, they're all very similar problems. Today's asynchronous anyways, just because of everything that's going on in the building. So try out the examples and then we'll go over questions if you have any.